let's talk about a definition. The discriminant is the radicand in the quadratic formula. Think about the quadratic formula. Think about, okay, it's if you have ax squared plus bx plus c equals 0. If you have a quadratic equation, the quadratic formula says that x equals, anybody have it memorized yet? That was very good. You guys need to work on your timing. You weren't quite in sync, but that was very good. Okay, the part underneath the radical, that's the discriminant. So b squared minus 4ac. You do not include the radical. It's the part underneath the radical on purpose. Okay, what does it mean to discriminate? I'm not talking about the awful sense of the word. There's a bad sense of that word, right? But there's also an innocuous sense of that word. To discriminate is just to tell the difference between, right? So that's where the word comes from, discriminant. That b squared minus 4ac allows us to discriminate or tell the difference between the kinds and numbers of solutions we get to quadratic equations. Think about it. If b squared minus 4ac is negative, what kinds of solutions do you get when you have a negative underneath the radical? Well, complex solutions, right? If we allow complex solutions with I in them, yeah. Whereas if b squared minus 4ac is bigger than 0, you get real solutions, right? So sometimes it's nice to know just what kind of solutions do you get in more advanced problems. Because maybe complex solutions don't apply, so you don't even try solving your equation if you get complex solutions. So that's what we use the discriminant for. Okay, so before we do an example, let me make a table here. Let's talk about the value of the discriminant versus the nature of the solutions to the quadratic equation, ax squared plus bx plus c equals 0. So remember, just as a reminder, the discriminant, d, we'll call it, is b squared minus 4ac. That's the number underneath the square root from the quadratic formula. If d is less than 0, so this is situation number 1. If d is less than 0, then as we already described or already talked about, you get two solutions to that equation, ax squared plus bx plus c equals 0. But what kinds of solutions are they? Two complex solutions. In other words, they involve the imaginary number I. Now, for whatever reason, your book calls it two imaginary solutions. That's actually not as accurate as it should be. It really is two complex solutions because remember, complex numbers have 1 foot in the real numbers and 1 foot in the imaginary numbers. So complex solutions are of the form a plus bi, right? Or a minus bi. So that's what you would expect. Now, if your only option is to answer using two imaginary solutions in MyMathLab, then you can choose that option. Okay, that's what happens when the discriminant is less than 0. What happens when the discriminant is equal to 0? How many solutions do you get, first of all? 1. Remember we saw that with the example earlier? You get 1. Okay, it's one real solution. But it's more than that. To be more specific, it's a rational solution. And of course, I meant to say 2 right there. Okay, what's the third possibility for the discriminant? D could be, how about greater than 0? In that case, you get 2 real solutions. And then it turns out there's a couple subcategories here. If D is a perfect square, then you get 2 rational solutions. Because that square root's going to go away when D is a perfect square from the quadratic formula. if D is not a perfect square, that radical is going to stick around. And anytime you have a square root of a non-perfect square, like the square root of 2, square root of 5, you get those numbers are irrational. So if D is not a perfect square, then you get 2 irrational solutions. Okay? So in many problems on the homework, you're not going to have to solve the equation. Keep that in mind. You're not going to have to solve the equation. You just have to categorize it. What kind of solutions do you get? Describe the solutions in this example. Describe the solutions to the given equation. Classify each solution or solutions according to number type. So in part A, we have x squared plus 2x minus 15. And it really should say equals 0. In part A, we have x squared plus 2x minus 15 equals 0. Okay, let's find the discriminant. And we'll categorize the solutions based on that table above. So D is equal to b squared minus 4ac. Can you fill this in for me? So find a, b, and c the same way you do from the quadratic formula. What's b equal to in this case? 2, so what's b squared? 4 minus 4 times what's a? 1, what's c? Negative 15. So what do we get? We get 4, what is this going to be? Plus, yeah, I have a negative and a negative makes it plus. 4 times 15 is 60. So the discriminant is 64. How does that compare with 0? So what kind of, okay, how many solutions do you expect to get then based on, well, let me ask you this. Which situation are we in? We're in situation 3. And then for situation 3, remember there's a couple of subcategories. So you can expect 2 real solutions because D is positive. The number underneath the square root from the quadratic formula is positive. So you know the plus or minus makes it, in the quadratic formula, makes it so you have 2 real solutions. But what kind do you expect to get? Is D a perfect square or a non-perfect square? It's a perfect square, so we're going to get 2 rational solutions. So this given equation has 2 rational solutions. They're real, so you could also call them real, but I'm just being a little more specific here by calling them rationals. A rational number is a type of real number.